Bismillahirrahmanirrahim. We start discussing the rest of our physics program. Okay, we're going to start from satellite. Satellite, the first nation, the first one who already set up a satellite, they was the Russian. They set up a satellite called Sputnik, and then another satellite is going to appear during this slide. What does it mean by the word satellite? Satellite means it is an object projected at a certain velocity from a certain height to rotate around the Earth in a circular path with a constant distance from the Earth, and this distance we called it the height of the satellite, which means the rocket goes upward till a certain height, then it projects a projectile, which is the satellite, to rotate around the Earth by a certain velocity. This velocity is called orbital velocity. The satellite needs this velocity to stay rotating around the Earth in a circular path. If the velocity increase or decrease on this, more than the orbital velocity or less than the orbital velocity, if it was small, the satellite will move away from the Earth. And if the velocity was less than the orbital velocity, the satellite will fall down on the Earth in a curved path. So this velocity is too important, which is called the orbital velocity, which means the velocity that makes the satellite orbit the Earth. Orbit the Earth means rotate around the Earth in a circular path by constant distance from the Earth's surface. The orbital velocity is so important, so the scientists try to discover how to calculate the orbital velocity. During motion of the satellite around the Earth, the satellite is considered as a projectile. It affected by a gravitational force, which comes from the gravity of the Earth, and also this force can be said it is one of the centripetal forces. So as we see here, the gravitational force act on the satellite is equal to the centripetal force which act on it. The rule of gravitational force means G times m1 times m2 over r orbit bar 2. G gravitational constant, m mass of satellite, capital M mass of Earth, r orbit, this is the distance between the satellite and the center of the Earth. R orbit means it is the distance between the satellite and the orbit of the Earth, equals mass of the satellite v square over r. V square, the velocity of the orbit, over r orbit, which is also the distance between the satellite and the center of the Earth. By cancelling mass with mass, we're going to discover that the orbital velocity bar 2 equal g times mass of Earth over radius of Earth. If you want to find the orbital velocity only, orbital velocity means or equals square root of g, gravitational constant, multiplying by the mass of the Earth divided by the radius of the orbit. Please remember, the radius of the orbit equals the radius of Earth plus the height of the satellite. And this radius of orbit must be in meter. The radius of orbit must be in meter. If it was in kilometer, multiplying by 10 power 3 to change it into meter. What are the factors that affect the orbital velocity? Number one, the orbital velocity inversely proportional to the square root of the radius. So as the radius increases 4 times, the orbital velocity will decrease to half because of the square root. If the orbital velocity, if the radius increase 16 times, the velocity of the orbit will decrease to quarter as a result of a square root. The second one, the orbital velocity is directly proportional to the square root of the mass of the planet. It is not necessary to be Earth. It may be another planet. So we can say that the orbital velocity of the satellite depends on the height of the satellite from the Earth. All the satellites which on the same height have the same velocity. all the satellites at the same height from the Earth have the same velocity, so they will not collide together. They are going to rotate near to each other without collision because they have the same orbital velocity. Another remark here, if the satellite stop, the velocity becomes zero, so the satellite will fall in a straight line toward the Earth. So if the satellite stops for a second, it's going to fall directly to the Earth's surface. The gravitational force between the planet and the satellite, if it vanishes, the satellite will move tangentially, like in the centripetal motion, because the centripetal force, which is the gravitational force, disappears, so it will move away like a ball moving away from a hand rotating it. To calculate the periodic time of satellite, to find the periodic time, it is the same. I'm going to use the same rule, which is circumference divided by the speed, 2 by r orbit over v orbit. Let's discuss some examples about satellite in this video, and I'm going to continue in the following video, inshallah. Number 1. If a satellite moves around the Earth in a circular path of height 940 kilometers, this cannot be used. It have to change into meter, multiplying by 10 power 3. From the Earth's surface, calculate its orbital velocity. If the mass of the Earth is 6 times 10 power 24 kilogram and the radius of Earth is 6360 kilometers. Also, the radius of Earth must be changed into meter. Let's see the answer. At first, the height multiplying by 1000, it becomes 9.4 times 10 power 5 meter. Mass of Earth and also radius of Earth multiplying by 1000, it becomes 6.3 times 10 power 6 meter. Before we start the problem, we have to find the radius of the orbit. Radius of the orbit equals radius of Earth plus the height. We are going to add the height with the radius of Earth. It will equals to 7.3 times 10 power 6 meter. Applying to the rule, V orbital equals square root of GME over R orbit, which equals 6.67 times 10 power negative 11 G times 6 times 10 power 24 divided by 7.3 times 10 power 6. By using your calculator, you are going to find that the velocity of the orbit is 7,404.2 meters and meter per second, and this is important to have. A measuring unit is meter per second. Let's see another one, please. He said that a sat move around the Earth in a circular orbit at height 300 kilometers. Also, I'm going to change this into meter. From the Earth's surface, calculate its orbital velocity and the time required for making one rotation, which means periodic time. If the radius is 6400 kilometers and the mass of Earth is 6 times 10 power 24 kilometers, we're going to change all kilometers into meters, and then let's see the answer. At first, the height after changing will become 3 times 10 power 5 meter. Radius of Earth becomes 6.7 times 10 power 6 meter. Mass of Earth 6 times 10 power 24. We calculate at first the radius of the orbit, which equals radius of Earth plus the height. Adding both of them, it's going to produce 6.7 times 10 power 6. Applying to the rule of orbital velocity by substituting by G 6.67 times 10 power negative 11, multiplying by the mass of Earth, dividing by the radius of the orbit, which we calculate before, it will be equals 7,728.6. This is the orbital velocity. But what about the periodic time? You also need to find the periodic time. Periodic time is equal to 2 pi r orbit over v orbital, 2 times by 3.14 or 22 over 7, as it's given in the problem in the exam. Times the radius of the orbit divided by the velocity of the orbit. After calculating it, it becomes 5,404.2 seconds. We are going to continue, inshallah, the problems in the second video, because the video maximum 10 minutes. Thank you for listening.